Hello friends, welcome back to our channel Crash Course for Engineers. Now we'll try to understand very important topic related to fluids. The name of the topic is properties of fluids. Now before going to the properties of the fluids, we need to know a few concepts, few terms. So first term is called as unit. Now units are the standards in terms of which the physical quantities are specified. Now, these quantities are divided or differentiated into two types. First is primary quantities or fundamental quantities. So, we know this mass, length, time, and temperature are called as primary quantities. Secondary or derived quantities, velocity, density, acceleration, etc. are called as secondary or derived quantities. Next is dimensions. The representations of secondary or derived quantities in terms of primary or fundamental quantities is called as dimension or dimensioning. The notation of dimension is m to the power a, l to the power b, capital T to the power C, small t is also there to the power d. So M for mass, L for length, T for time, and small t is for temperature. So mostly we represent the secondary quantities in terms of primary or fundamental quantities by using the term dimensioning. Now, very first property of the fluid is mass. Now, this mass is a quantitative measure of matter. The notation of mass is small m. The unit is gram in CGS and kilogram in SI system. Mostly we use kilogram or we are following the SI system in India. So we use kilogram. What about the dimensioning? So m to the power 1, L to the power 0, and T to the power 0 is the dimensioning of mass. Second quantity is mass density. Now this mass density is a mass per unit volume of the fluid. Now here body is written, so I need to say the fluid. The notation is rho. Okay, so rho is equal to mass divided by the volume. So more the mass density, the fluid molecules will be closely packed, and lesser the mass density, the fluid molecules will be lesser densely packed. The unit is gram per centimeter cube or kilogram per meter cube. So the dimensioning will be m to the power 1, L to the power minus 3, and T to the power 0. For some familiar liquid, the mass density or simple density. The values are 1000 for water. For mercury, it is 13,600, and for petrol, it is 730 kilogram per meter cube. Next property is specific weight. Now, what is this specific weight? So, specific weight, it is also called as a weight density. It is similar to the mass density, just it is a ratio of weight to the unit volume of the fluid. So, we say specific weight, the notation is gamma is equal to weight divided by the volume. What is the unit of weight density? In SI system, the unit is Newton per meter cube, and the dimensioning is m to the power 1, L to the power minus 2, and T to the power minus 2. So there is a relationship between mass density and specific weight. So we say that gamma is equal to W upon V, but W is equal to M into G upon V. We know M by V is rho, so rho into G. So gamma is equal to rho into G, or we say gamma is equal to rho, sorry, rho is equal to gamma upon G. Either the relation we use. So here for water, gamma for water is equal to rho of water into G. Density of water is 1000 into 9.81. So 9810 Newton per meter cube. The value is this. Next property is the specific volume. Now, what is the specific volume? The ratio of volume of the fluid per unit mass of the fluid is called as specific volume. The notation is Vs. So we say volume of fluid divided by mass of fluid. So by the definition of mass density, I can say it is the one reciprocal of mass density. What is the unit? So unit is reciprocal of mass density, so meter cube per kilogram, and the dimensioning are m to the power minus 1, L to the power 3, and T to the power 0. Now, next property is specific gravity. So, it is a ratio of specific weight of the fluid to the specific weight of standard fluid. So, mostly we use water as a standard fluid. So, S is equal to gamma of the fluid divided by gamma of water or H2O. So here this is a dimensionless quantity as both the dimensions are cancelling out. Now the specific gravity of water is equal to 1. We can say that the specific gravity of mercury is 13.6. Okay. In many of the cases, the specific gravity of the liquid is given, and that's why we need to use this value, or we need to remember the relation. Now next term or property of the fluid is viscosity. So what is viscosity? Viscosity is defined as the property of the fluid by virtue of which the fluid offers resistance to deform action of shear stress. Now here, if we uh, take this example, so now suppose there are layers of the fluid, many layers of the, so we say that fluid over a surface, or fluid when there is a flow of the fluid. So these are the layers of the fluid. So suppose this is the surface and the fluid is flowing in this direction. So what will happen? Each layer will offer resistance to the other layer. So this resistance is nothing but the property which is called as the viscosity. So what is this viscosity? It is defined as the property of the fluid by virtue of which the fluid offer resistance to the deformation under the action of shear stress. Now, what is the formula for dynamic viscosity? So it is force upon area into time. So Newton second per meter square. So force upon area into time. So dimensioning will be m to the power 1, L to the power minus 1, and T to the power minus 1. Now this viscosity is called as a dynamic viscosity. One more viscosity is there, which is called as a kinematic viscosity. Now what is this kinematic viscosity? It is a ratio of absolute viscosity to the mass density of the fluid. So the notation is nu is equal to absolute or dynamic viscosity divided by density. So what will be the unit? So we have this unit length square per time, or meter square per time. Okay, so in SI system the unit is meter square per second. The dimensioning is very simple. Nu is equal to m to the power 0, L to the power 2, and T to the power minus 1. Now, so friends, these are the very important properties that we see in fluid mechanics. Apart from this, there are some more properties. So we'll see those properties in the next video. If you have any query regarding the contents of the video, please put it in the chat box. If you like the video, please subscribe the channel. Thank you.